So we can start this by setting up a free body diagram. For the motorcycle, we would have the normal force and the force of gravity equal and opposite. So we don't really care about those so much. What we're looking at is the difference between the force of friction and the applied force. The vertical forces cancel, they're equal and opposite because the motorcycle is not going into the ground, or it's not being lifted up off the ground. And so the net force will be in the horizontal direction, and to find the net force, we will add them. Now remember, when we add forces, the forces are vectors with a magnitude and a direction. So we have to define the positive direction, which is typically up and to the right, as you're used to in Cartesian graphs. So since the force of friction is to the left, that would be a negative value. So we'll find the F net as 2,000 newtons for the applied force, plus our negative force of friction, negative because it's going to the left, of 90 newtons. This gives us a net force of 1910 newtons to the right. We don't need to write this, but just gives you an idea. Remember, when you're given a mass and a net force, we can find the acceleration. So we have F net equals the total mass times the total or net acceleration. This is Newton's second law. Force is proportional to mass times acceleration. And we have the force and the mass, so we can isolate for the acceleration, and then we'll use that later in our kinematics equations. So let's see what this gives us. This gives us 4.775 meters per second squared. To find the time, we use the three kinematics values, V1, V2, and A, in an equation with time. So you have to remember what that equation is. We have V2 equals V1 plus AT. And rearranging for time, we have T equals the difference of the velocities divided by the acceleration. This gives us 6.3 seconds for the motorcycle to accelerate to the final speed.